set up. But technology is great and it will work. So I don't need to introduce myself. I've been involved in the internet governance game for a very long time. And then, well, my thesis was actually about reduction of delay in asynchronous transfer mode networks, which doesn't mean anything to anyone, including me, now that I read the thesis again. But it was good, apparently, and it got me to understand really how the internet completely works. We're going to look today. I was supposed to speak for 40 minutes, and then when I sent the slides, as you heard yesterday, there was like 99 slides. They're sort of a. You have your phone. It is on.
Hello. Okay, so it is on.
I have to speak louder?
No, we just put the volume up a little bit. Okay, put the volume up, yeah.
And so I have 99 slides, which are actually a collection of slides that I've presented over the years. And you start with a presentation that's actually normal, that's about 20 slides, and then over years, people ask you questions, you think, maybe I should be answering this question too, and this is a really important part that we need to talk about. And I thought, okay, instead of having like, these boring things where you have one slide, like this one, for example, and talk and ramble about it for 5 minutes and people doze off and check their emails and all this, I thought let's keep everyone on their toes and go through some slides quite quickly as well, because the visuals are nice. It's something to if you don't understand anything, you're like, oh, this is a nice drawing. Oh, this is pleasant. There's some interesting thing to it. And the internet history is actually a little bit like this. It's gone so quickly. When you compare it to other types of histories that are out there, you're talking about 10, 20, 30, 40, 50, 60 years, or hundreds of years, and the internet really happened in a very, very short amount of time. You're looking at the 70s and the 80s, and then afterwards all the commercial wave that came over without anybody really being in charge or understanding what the heck is going on or where we're going. Don't believe what's written in books that, oh, there was a plan to do this and a plan to do that. The reality of it was that there was indeed a plan, but on day 2 it went straight in the bin and things just took over and went really, really fast. So I'm going to talk a bit about this, talk about from techies to lawyers, lawyers to politicians. I'm a techie to start with. I ended up speaking to lawyers at some point. I know it's difficult for a techie to do that, but I sort of went along. It's difficult for a lawyer to talk to a techie because they speak different languages. And then talking to politicians is different for everyone because you don't really know what politicians are talking about. And then afterwards I'll tell you about the various organizations that are out there. You can see a whole sea of acronyms that you have. And then the big issues, and the main one being this whole concept of multi-stakeholder versus multilateral. That's something that is key to all of the discussions as far as the internet is concerned. And then finally, we'll have some questions and answer. And I hope to finish quickly enough so as to have a lot of questions and be able to provide a lot of answers. All right, so first thing, start with the boring stuff, the definition of internet governance. It's in 2005, which seems to be a long time ago, more than 10 years, but in fact it was really late in the game that this WGIG, World Group on Internet Governance, came up with a definition of internet governance. It's sort of UN-type language to define what internet governance is. And when you read it, internet governance is the development and application by governments, the private sector, and civil society in their respective roles of shared principles, norms, rules, decision-making procedures, and programs that shape the evolution and use of the internet. You will notice that the person that wrote this had very big lungs so as to be able to read it in one go. It was actually a group that put it together, and it was a consensus, basically, to say, look, this is how we can describe it in one sentence as such. I think they did quite a good job, because it does encompass the whole thing of having, well, the 3 component parts, government, private sector, and civil society, that all work together. They did have to add in their respective roles, because at the UN, nobody wants somebody else to work on your patch. So, countries are very worried about this whole thing of private sector doing their job, and civil society is very worried about companies overreaching and so on. So that kind of was a good definition to start with. And everything else that derives now from internet governance, whenever there is a whole disagreement in any discussion that takes place, people always go back to the definition and say, wait a minute, but we've defined this back in 2005. Why are we reopening the issue? And the whole thing of reopening issues is the traditional thing, the way to actually get things delayed. Well, you know what, let's go back to the beginning, because I don't agree with what we discussed 5 years ago, so let's start again. There were 5 waves of internet, really, when you look at it in sort of the big picture. So there you are, leave the Earth, you go on Mars or someplace far away. You say, right, the first wave was from 57 to 70, and that was all the military that basically said, we need a network, we need something that is going to be able to sustain a nuclear war that will keep our communication channels open. And not only that, these guys, the Russians have launched a satellite into space, Sputnik, and we need to do something equally as important than they can. We're not able to launch a satellite just right now because our rockets blew up on the ground, but maybe we can do something like a network that if these guys get us, we'll still be able to talk to each other. Okay, fine. Talk to each other being, of course, the military being able to talk to each other. And that went on all the way to the 70s. And in fact, had it been something else where, for example, it would have started commercially, the internet would have never happened, because so much money had to be poured in the whole technical preparations, the research, all of that. And you'll see in a second how much work was done to reach that level. It needed to be a military operation. Only the military can say, you know, give us $10 billion and we'll do something, but we can't tell you what we'll do with it. You go to any VC firm and say, I want 10 billion. I have a project which is great, but I can't tell you about it. You're not going to get anything. I don't know if anyone, do you have tried or no? No, I've tried and it hasn't worked. So now then after that, in the 70s, because this military network thing seemed to be working and a lot of university research departments were involved into it, then you ended up with an academic wave where it started just moving into academics. The military was still there. And of course you had a few corporations by then to supply some of the equipment, and that's when you started getting corporations coming into it. Mostly the manufacturers of the equipment that was used for building the internet. Those guys then suddenly found that the internet was really cool to be able to work with each other, much easier than the phone or the fax or, God forbid, the telex, which is what used to be used back in those days. And then they started using it commercially. Then of course you had a whole thing, World Wide Web, WWW, that sort of, you know, turned the tables completely upside down, and it became super commercial. From there it became onto mass media, because the telecommunication means we're getting better and better. So you ended up being able to have YouTube and video on there. And the moment you get video, you get mass media, advertising, all of that really going crazy in the sort of early 2000s. And then after that, because everyone had good bandwidth at home, it became the whole media of saying, I think it was called Web 2.0. I don't know if any of you remember this thing called Web 2.0. I don't think we even bother now in saying if it's 2, 3, 4, 5, whatever, but it's one of these things where everybody and anyone can send any amount of quality content, crap, on the net, and you know, their daily life, they're vloggers that have 200,000 or 1 million subscribers just to see the person brush their teeth every morning and say, hey, what am I going to do today? But anyway, so that's the whole thing. And of course, you've got all this new internet complexity with all of these new devices are going to be connected. So not only will you be able to write a vlog, but your shoes will be able to write one, and your car, and you know, the life of a car, the daily life of a car. So I drove in a traffic jam this morning, because you know, self-driving cars. All this stuff is going to happen, and we know it's just going to go even wilder. And something has to happen to make sure that it's still going to work and not completely collapse. But we'll see in a moment. So let's go back to the beginning, the history. Developed in the 1960s, there were technical specifications that are held by the Internet Engineering Task Force, the IETF. It's a multi-stakeholder environment, so anybody can go to the IETF and start working on standards. The Internet is a distributed system. People always forget, it's a network of networks. When it was built, it wasn't just like one authority saying, right, now we're going to add this computer or that computer or that computer. No, it was a case of like, oh, this network wants to get connected, okay, follow the technical standards and you can get connected. And that's how you got this whole attraction, a little bit like a magnet attracting other, attracted other parts wanting to come closer to it. This is why I laugh these days when you have countries that say, we're going to have a new internet, we'll create our own internet, and we'll cut ourselves from your internet. Be my guest, go for it, because I remember 20 years ago you were begging to go on this one. So if you don't like it, just go, do your own. And of course, that's just empty threats. There's a hierarchy there's only one hierarchy that actually is top-down, and that's the domain name system. It's a single method of addressing across all of the different subnetworks on the internet, so as to make sure that when you send something to A at B.C, there's only one A at B.C, otherwise it would get really, really confusing and things wouldn't work out. So that's why the DNS has been put together, and I'll show you in a second what it was like before the DNS. The ecosystem itself, so now we're talking about the overall environment of the internet. It's successful because, as I said earlier, no single owner of the internet, which means that everyone is able to either govern or run their part of the network according to their own rules. They might wish to impose it to others around them, but at the end of the day, everyone's got their own jurisdiction as they wish. It's freely accessible that's what, you say the internet is free. Well, it's not free as in cost-free, but it's free as in you should be able to access it as you wish to access it, depending on your own rules. So it's open, transparent, collaborative. These are core issues. The internet wouldn't be the internet if it didn't actually have these points. It might be a network of some sort, but it wouldn't have grown to the same level that it has today. Now, some people argue that yes, maybe it would have been different, maybe they would have grown anyway, but the networks that actually were different from the internet, and there were several other networks out there, both technologically but also in the whole societal aspect of it, did not succeed. At some point, they just joined the internet itself. Now, let's go back to 1961 and talk about the real deep technical basis of this whole thing. A guy by the name of J.C.R. Licklider. Now this is, it's sort of, we're talking about 61. So in 61, it's Professor Licklider, so nobody really knows the guy's first name. Same sort of thing as J.K. Rowling. No, sorry, that's a different era. Okay. You have a number of people like H.G. Wells. What was the first name of H.G. Wells? Harry, perhaps, yeah, or
Happy.
Or Hector, who knows? But anyway, J.C.R. Licklider was a guy from the MIT, Massachusetts Institute of Technology, and he, in response to this whole Sputnik thing, said, you know what, we need this whole concept of a galactic network. Like we're going to be able to connect planets together. And then he came up with this whole difference between the sort of galactic network. We need some kind of communication system that will allow for all of the different types of communication to be multiplexed onto one line. So when you have 10 different people talking, there needs to be something that actually gets those 10 communications through. And rather than being a system where you have a circuit switching, where you have the phone operator that connects this with this, and then this with this, and then you end up with like 1,000 connections across the room to be able to connect everyone to everyone else, you have a concept of going into packet switching, where the information is digitized and cut into small packets and then sent, a little bit like in the post, and then at the other end it's redistributed, and all of that involves a lot of mathematics. Leonard Kleinrock wrote a whole book about this thing. When I did my PhD about queuing theory, I think I learned, that was the first book basically I had to read through. This guy was my god and my devil at the same time. I hated the guy's guts. I met him a lot later. I said, I'm really sorry, but I hated you for a few years because you just put me down this mathematical downhole. It was terrible. But anyway, he developed this whole theory, and effectively you can mathematically model any type of queuing system. So whether it's a traffic jam or a queue at the post office or somewhere else, it can all be done mathematically. You can predict how much time you have to wait. This is actually how this whole queuing theory, the people that spend their life working on queuing theory, and you end up being able to optimize this so as to have less traffic jams or less queues at the post office or less queues at the airports. Although you will have noticed that everyone has failed to find a solution so far, because we still have traffic jams, we still have queues at the airport, and we still have queues at the post office. So that was the first thing, 61. And so then a bit later on, in 69, so Kleinrock and a few other people over at UCLA decided, right, if we actually use this theory and these protocols and get two computers to talk to each other, maybe then we can, that's the first start if you want to moving forward. And so the ARPA network was born in September 1961 with one node. Well, actually one node, not quite. It really is two nodes. It's like, IMP, UCLA, and you've got so IMP is the sort of message protocol telecommunication box, and you've got the host, the computer that can talk to the box. So box, computer, they can talk to each other. Step one, done, tick. December 69, so note how long it took to actually go outside the office. In December 69, they managed to get UCLA, Stanford Research Institute, and UCSB to each have their own IMP and then their own computers connected to them, and get those three to talk to each other. And that really was the first packet switching on a sort of a wider sense than just talking across the lab, but actually managing to go from one place to another. Very quickly, seeing this, one needed to write a document about it. And the early notes were all like, handwritten and then typed very hastily and stuffed in a drawer somewhere. But from the time that you were in this position with three computers, different campuses, then you have to start photocopying it and then carrying it in a briefcase or in a bag or whatever it was to the other people, and papers get lost and all that stuff. And they said, look, we need some kind of a system to reference all of the advances in the work that we're doing. And this is where the request for comment series, the RFC series started. And it was not a case of like, let's write a standard, but it's, okay, here's what we've done. What do you think about it? So they were requesting comments from the wider community that was looking at what was going on here. And a gentleman called Steve Crocker, and I don't know whether he's going to come to this meeting, but he was the chair of ICANN all the way to the last ICANN meeting in Abu Dhabi. A gentleman of Steve Crocker, who is of a certain age, was the guy that wrote RFC1. It's a nice claim to fame. Well, of course, he was not only wrote this, but he was part of the really inherent part of the group that developed this whole network. So RFCs have become since the standards of the internet, and we'll be speaking about them in a moment. In 71, so now you're jumping 2 years forward, look how many more computers were there. So you got all these IMPs that we were talking about, more locations, so Harvard and, do I have a pointer? Oh, here we go. So you got Harvard, Burroughs is a company, Carnegie Mellon, Case is also an institute, Lincoln, MIT, Illinois, Utah, Stanford Research Institute, you see here. Stanford and UCSB and UCLA have now got still their, circular network, but they put more machines on it. And you're starting to talk with more machines, talking to each other. And by talking to each other, how do you talk to each other? Well, first thing, you need to write something and a system to be able to transfer that. And that's the first electronic mail. That was put by Ray Tomlinson.
IMP stands for what?
Internet, no, what was it?
There you go.
No, it's a really old thing. No, I had it earlier. It's the message protocol or something.
Okay,
it's one of these really old boxes, basically. It's like a transfer box, telecommunication box of some sort. Like TNC, Terminal Node Controller. How many people have heard of TNC? No one, exactly. So nobody's heard of IMP, nobody cares. But it's just like a message machine, effectively. So first electronic mail sent, Ray Tomlinson decided, hey, I'm going to write a little software for this to work. And this was using, this whole network continued growing. You can see in 73, with so many more nodes. You still have the SRI here. Now you've got a whole lot of other machines that connected to it, and across the US as well. So Harvard and Carnegie and all this. And then you've also got the first international connection, which goes from SOAC, which I believe is some kind of a government department, over to NORSAR, which is a satellite thing, goes over to London. And so London, with my good friend Peter Kirstein, was the first place outside of the United States that was connected to the internet. And that was no small feat, because everything else was using landline communications for the most. But here you ended up with a satellite link, and that introduced this delay, introduces all sorts of complexities. At the other end, here's another strange link. That's the one over to Hawaii. And it's funny that Hawaii was connected after everyone else, after 6 months or 8 months after, because actually the whole concept of packet switching technology started in Hawaii with the Aloha Net network in the sort of late 60s or so, where they had these radio systems that would talk to each other and they could actually get messages across all of the islands at no cost whatsoever. You're talking, you know, the 60s and 70s. It's even making a phone call was difficult back in those days for many of these places. So it was pretty terrible. Now, you know, 73, it wasn't using TCP/IP, which we'll look about in a second. It was using a protocol called Network Control Protocol. It had its limitations. It worked, as you can see, but it wasn't perfect because the more it wasn't scalable. So the more machines you have, the more problems you start having. So it was obvious that something had to be done to have computers talk to each other in a way that would not only regulate the flow of information that goes through, but make sure that the information that is sent through doesn't have errors. So there was error checking, etc., etc. And that's where two people who at that time were young students with under the stewardship of a gentleman called Dave Farber, who I saw 2 days ago in ISOC, New York. And this is funny. Dave Farber, who are you? I'm the grandfather of the internet. Why? Because these guys are seen as the fathers of the internet. Vint Cerf and Bob Kahn. Bob was working for BBN, Bolt, Beranek, Newman. He was one of the contractors, defense contractors. And Vint was over at Stanford. And his supervisor told him, Vint, you need to develop something that is going to ease this problem of scaling up, because this network is getting bigger and bigger. And they came up with TCP/IP, Transmission Control Protocol / Internet Protocol. It's two different layers. Okay, I'm not going to go so technical, but it's two different layers of protocols, but the two work together, and today they still work to do what it needs to do. It's quite unbelievable that it's scaled up so well that it works this way. Oh, there you go, you've got the picture. So Dave Farber, Steve Crocker, and Vint, the three of them here.
We can definitely see that.
You can see them, yeah. They're so huge they can fit in that phone.
It's the same as my name tag, so.
Same as your name tag.
Should be good.
Equally as big. So these guys developed TCP/IP. That was implemented because it was pretty easy. Look, I mean, okay, you have quite a few nodes, but you probably know everyone on the net. So you call them up. You say, okay, we'll send you a reel of tape. You load this in your IMP, and bang, it will all work out. And sure enough, it did work. And you ended up with this more complex network. So you got that, and then it became 77, even more. And you can see there is a pattern here. There's a pattern. There's more people coming in. There's nobody leaving. So wow, the party's starting to get a little crowded, but you still managed to know each other, you know, because you had these IETF. It wasn't a formal meeting, but you could kind of meet up. Be like, okay, let's go to San Francisco next week, and on Tuesday everyone will meet up in this warehouse, and we'll see, you know, and 30 people turn up, and it's like, oh, that's the whole network represented. Excellent. And so all these people were working on this, and then 82, you know. Here you can see you look at different computers at each node. But of course, once you've got a node working, you can have 1, 2, 3, 4, 5, 6, 7. You get more money, you buy more computers, you put them on there as well. So then they started talking about sub-networks. So UCL, which is University College London, had its own network. And there was the satellite network, and there's the Bold-Beranek-Newman network. And all the different places moved from being nodes, a single computer with a single IMP, to an actual full network being connected there. And then it didn't really matter whether you had one computer or 10 or 100. It was your network. You would run it how you wanted it, and you could grow it independently of everyone else, as long as you were continuing to respect the protocols. And you can see here the TCP/IP, the IP addresses. You see like 10.3.0.40 and 10.3.0.17. These were all the TCP/IP network numbers, and you know, so it kind of worked quite well back then in 82. In 85, there was a bit of a change, because now you started knowing people a bit less on the internet. Before, you know, 30 people, everyone in the room, that's it. We run the net, we know what we're doing. But now you start having more and more universities, more and more companies going on there. Companies weren't much of a problem because employees generally are worried about getting fired, but universities are a bit of a problem because students usually, they drink too much, they party too much, and they hack too much. Three things that are connected well together. We know that the best startups out there work with alcohol, partying, and work, and hard work. And who means hacking? What are you going to hack? Are you going to hack the university's computers? Well, that's a piece of cake. That's like, no, you want to hack the military. The military, that's the thing, You have this whole thing, what was there was a film, wasn't there, on there? Not Star Wars, the other one. The,
War games.
War games, that's it. War games.
Global nuclear war.
Do you want to play global thermonuclear war? I was a student back then. I dreamt of launching global thermonuclear war. I had my barbecue set outside, ready for the rays to hit down. Well, I hadn't, but to cut a long story short, they started getting a lot more security breaches and problems. And I remember actually, so we're talking 85, in 88, I remembered when I started using the internet, the first thing I met was a senior student at university, and he goes, let me show you something. And he did a few magical things on the computer, and we ended up with Defense Communication Agency. And it like goes across like this, and you're like, ooh, I should be seeing this. This is exciting. Yeah. Let's see, what else can we do? And that was exactly it. So they basically started cutting their links and making their own network, and with a smaller number of entry points into their own network. So it became like Milnet on one side, ARPANET on the other, and then the satellite stuff and the wideband network on the other. We continue. The host tables. So until then, you still didn't have DNS. So what you had were all these IP addresses that you see on the left-hand side, as I gave you earlier. And so either you were...
DNS?
Oh, dynamic naming system. Or distributed naming
It's
system.
a domain name system.
Domain name system. You know what? No, I called it dynamic because the original name was dynamic. It was
really?
Yeah, they weren't thinking like
Remember
this.
the acronyms?
But yeah, so many acronyms. It doesn't matter what it's called. It's just there. Anyway, you had these IP addresses, and as you can see, unless you're a math graduate from MIT and you got a head for numbers and you can remember thousands of phone numbers, you can't really remember all of the different things. So you need to have some names that come across with it. And as you will see, I mean, this is an example of a host file which I had around that time. And so this is sort of my own personal archives, and you can see the typical student. What machines did I select? I selected all the bloody military computers for some reason. I have no idea why. It was probably more exciting. Anyway, this has got a name next to it, and it shows you if it's a gateway or how you get to it. And the host tables had to be updated manually. So when you were at a university or a department adding another computer on there, you would basically send an email with the whole details over to the registry table, which was run by nic.ddn.mil, the Data Defense Network, and they would have someone over there who would add it over to the host table. And of course, it started as a part-time job, just a few machines every week, but then as things heated up, there was more and more and more. And the problem that you had is with all of this stuff, you just ended up with too many updates. How the heck can you update, 1,000 new machines every day manually so you don't make any mistakes with this stuff? It started becoming a bit difficult. Not only that, you just had .mil, you had and .arpa at the beginning. You can see here, everything is .arpa and .mil, and there's a thing that goes between the two. So it's either .arpa or .mil. But then the domain name system was introduced that had .mil, .gov for government, .com for commercial organizations, since Digital Equipment Corporation was a commercial organization, .net for subnetworks, .org for not-for-profit organizations, and .edu for educational establishments. That gave a little bit more space for the namespace in itself. And of course, back in 1985, it was just a question of like 10 people going around the room and saying, right, are we going to put this thing together? Yeah, okay, done. No ICANN, none of this rubbish stuff. It's like, and so you ended up in 1988 with a host table that, so you had two host tables, the one with the IP addresses, and then another table that was giving you the name of each one of those establishments. So you'd have something bbn.arpa, and that was BBN Communications. You had universities, you had commercial organizations, etc. And that's what part of the host table looked like. Aside from all of this, you had a thing called Usenet. So this was all run using big computers. So you're talking about IBM mainframes and DEC, Digital Equipment Corporation mainframes, big machines that cost a lot of money to run. That's why it was military, large corporations, and large universities. But those people that were working there at the same time had a real feeling, thinking, well, wait a minute, maybe I can use this email stuff and transfer files back home using a low-cost solution. Now you have to remember, this is 1988. In 1988, you started having PCs. You started having these desktop machines that could do all sorts of stuff. And they thought, why don't we just write some kind of software that can get the machines to talk to each other and transfer files. And those files could be an email, or it could be a file transfer of some sort. And they thought, okay, we've got that on one side, and we've got this other software or operating system called Unix that was, again, developed by these defense-related projects. This stuff is in the public domain somehow. We'll use this Unix thing, we'll run it on the boxes, and we'll get those boxes to call each other by dial-up. And this is what the UUCP and UUNet and UUCP protocols did, to then build a network of computers that would then exchange like bulletin board information with each other. So you had these news groups that would be peer-to-peer. You know what peer-to-peer is? So like, you know, you've got a full copy, you exchange with your colleague, then your colleague exchanges with everyone else, then everyone exchanges things with everyone else, and so everyone ends up with the same information. So this basically spanned the whole globe. Some of it was using leased lines already because it was big universities or big companies that were connected together already, and some of it was actual dial-up. And you can see that it was spanning throughout so that's like throughout the US. You can see here that you had Europe that was connected, and you had other parts. So that's Georgia Tech here, that's Digital Equipment Corporation, that's KDD Lab, that's over in Japan. Math Centrum Vax, that was in Amsterdam. UUNet was over in Herndon, Massachusetts. Munari was in Australia somewhere? Munari. Yeah, no, yes it was. Also AU, yeah, it was in Australia. Anyway, so that was one of the things that was going on in parallel. And so you ended up with large networks on the one side that were connected to the internet. So you got Milnet, CSNet, and then all these other ones which actually were like started by independent organizations and connected themselves. Then you had BitNet, which was something completely different, which was a store and forward network, only using really, really large computers and with well, running on a different set of protocols. A set of protocols run by the ITU, and we'll touch on the ITU shortly, International Telecommunication Union. So those protocols were something else. There was the Usenet stuff, and you had 30,000 nodes. Now you can imagine 30,000 computers and well, nodes connected. That must be the end of it. You don't need any more. The whole world is connected now. Why do we need more than that? I mean, 30,000, you know, it's more than anybody ever thought there would be. So in '89, because of all the hacking, Milnet separated itself completely and just had a handful of gateways to the rest of the network. The commercial organization started really pushing, and so NCI, I don't know what NCI stands for actually, but it was a US telecommunication company, NCI, that happened at that point to employ Vint Cerf. So he left the university and he went to work for MCI. And they started a commercial email service. Did Vint have anything to do with this? Yeah, I wonder. And then the rest of the ARPANET was actually still a little bit chaotic. So most of the maintenance costs for the network were still paid for by either the US government or by universities. And more commercial organizations started using it for their own purposes. And so in January 1989, you had 80,000 nodes, and then it doubled to 160,000 nodes by November. Now you can imagine the chaos that followed with the some US congressmen looking at this and thinking, wait a minute, the costs for running this network is suddenly going really high, and it's my taxpayers that are paying for this? What are you talking about? I don't want any of this stuff. And so they really started getting concerned that you had all these commercial organizations, PSI, UUNet, and CORE, to start commercial services but still use the basic infrastructure that was mostly paid for by the US taxpayer and other taxpayers in the rest of the world. The NSFNet was created, and it created this educational network with acceptable use policies. And the acceptable use policy was, you can only carry non-commercial traffic on this network. We will filter it, we will look at it, and if you carry commercial traffic, you're out. That's when you started getting this whole separation of the different networks and saying, well, the educational stuff is going to go on one network paid for by taxpayers or by universities. The government stuff will go on another network, and the commercial will just have to do something to be able to talk to each other, but they all have to pay for it. And that's where this introduced the whole thing of peering agreements. So company A and company B each have their own networks. They want to talk to each other. Company C arrives, so they say, right, I know company B. I'll work with company B to get connected with them. Company B then says, okay, I will agree with you to carry your traffic to company A if you agree to carry my traffic to another company. And so everyone decides to, they write peering agreements to then carry each other's network, each other's traffic, which means that your company doesn't need to buy a network that spans the whole world. You deal with your part of the network, you carry other people's traffic, but the other people also carry your traffic. And that's the basic point of the commercial internet that we know today. More services started, the services in 1990 and 1991. And this is funny because I recall talking to some people in telecommunication companies back then and saying, the internet is going to be so big, you guys have to be there right now. In the States, it's really taking off, so you have to be there. And they looked at this and said, we have electronic mail, okay, that could be useful. File transfer protocol, okay, fine, not exactly the easiest interface to use, but fair enough. Gopher, I'll show you Gopher in a second. Wide area internet server, Archie, and Telnet. All of this stuff was really very geeky, just text-based, basically, yeah? Telnet was to log into a computer and then speak the language of the computer, whether Unix or VMS or CMS or whatever it was. All of that was pretty cryptic. Apart from email. Email perhaps was the more consumer-friendly stuff that came up. This is a Gopher stream. This is from my own archives, actually. Back then, I took a screen print or cut and pasting, and I put it in a file. And so you had it was like the hypertext based, so you could move the thing by your arrows, up and down arrows, and you had this little arrow on the left that would move up and down. You can choose this, or you can type the selection that you want, and it would go into there. Or you could do a left and right, you see in some sentences you might have these little squiggly brackets, sort of chevrons on each side, so you would move there and click on it. Hypertext itself was not invented by Tim Berners-Lee, who we'll speak about in a moment. It was actually invented in Xerox Palo Alto Research Center, Xerox PARC, and Apple Computer was the first company to actually make use of this hypertext thing. They actually called it hyperstack, I think, if I recall correctly. Yeah. So and so these guys said, oh, let's try and do this on the internet, and this started with this. It was helpful. I remember having some Gopher pages back then. I put together a few pages and stuff, and I don't know how many people were reading them, because there weren't that many people on the network, but it was running in this way. You then ended up with these companies doing these peering agreements with each other. Now, we're still talking 91. Deciding, maybe it becomes a bit more clever if instead of each one connecting to each other and carrying each other's traffic, why don't we just have like a specific number of points? Because now we're 30 different companies. Why don't we have like a neutral access point, like an internet exchange? That's a good idea. And so they started the first organization that ran an internet exchange, and it was called CIX. And there was 3 main signatories, PSINet, UUNet, and SurfNet. Each one of whom had hundreds and hundreds of clients already. So they would peer in one location. And that's how you started having at least 2 main peering points in the US, which was NAE East and NAE West. So the big computer places where everything was connected. Matthew.
My first email address was 1992 on SurfNet.
1992 on SurfNet. Oh, there you go. So
Pretty cool.
right there, one of the pioneers. So then you had the first neutral exchange point that was bypassing the NSF net backbone, because remember, 2 years earlier, the NSF net said, we don't want any more commercial traffic. But this is another thing of the internet. You can put a rule, and then it takes years to enforce it, because there's nobody there to enforce it. I mean, there was no NSF net police to go and say, you bad person. Especially if the infringer was a company like Digital Equipment Corporation that was equipping half of the universities with computers at good prices. Why would you want to kick them out? You don't want to do that. You don't want to, bite the hand that feeds you. So it was a little like this, but with time, they all started moving completely into the commercial space. And so there was the concept of exchanging traffic between commercial internet service providers. So we're not talking about end companies anymore, and now we're talking about companies that connect other companies for a living. And that's only 1991. It's not, well, I think it's not a long time ago, but you might think it's a long time ago. I don't know. It's, so 92, this guy who was totally unheard of, a guy called Tim Berners-Lee invented HTML. And that's the markup language which you all are aware of now. The big difference between Gopher was that HTML also managed to have tags for images, for non-text in there. And you could also use your graphical user interface to click on things. Remember, 92 is the time when Windows went from the basic Windows thing where you had to type Win on your text, DOS text line to launch into Windows, and 2 times out of 3 it was crashing, it was slow, it wasn't working. In 92 they had another version which became a little better than the previous one, so more people were using Windows. So more people had the graphical user environment. The PCs became more powerful, and at the same time, these people are over in the University of Illinois at Urbana-Champaign, young students over there, decided, we've heard about this hypertext markup language, maybe we can write also a browser that's like a free browser for anyone to use. And that's how NCSA Mosaic was created. That was the first thing. Now, what does NCSA Mosaic look like? That's the screen print of NCSA Mosaic. I don't know if many people have a print. So again, from my own archives. You have one? Oh, there you go. So that was one of the first things. I remember then going like, okay, I need to get on a good website. And the IBM website was really cool because it had so many pictures. And not only that, they had the chairman of IBM, look at that, Lou Gerstner, chairman of IBM. On behalf of all of us at IBM, I'd like to welcome you to our World Wide Web server. Whoa! Amazing! And that was actually pretty much anything they had, because you can see there's not very much else you can check there. You know, there's industry solutions, products and services, technology, about IBM. That was it. 6 different pages underneath the top page. But they were there back then. That was in 94, so you're talking two years afterwards.
The government had also 94. MIT created.
MIT, the US universities were on there big time.
Right, but the first US government one was done.
Was it only in 94?
It was done in 94, and it was done in September, and it was done by people at MIT.
Yeah.
So the first one was done, I was working on that back in 1994, was done by MIT. They saw what was out earlier, and they got the technology people at the White House were working, and they got the White House.gov set up in 1994 in July.
So you mentioned whitehouse.gov. So it was Bill Clinton, I think, that was in the White House at the time. And so you had president at whitehouse.gov to contact the president. They actually gave an email address for the president. Of course, he wasn't reading it, but his staffers or something were reading it. And then you had vice president at whitehouse.gov. But if you wanted to talk to the boss, if you wanted to talk to Hillary, you would write to root at whitehouse.gov, and that's the systems manager. That was the joke at the time, by the way. You want to talk to Hillary, she's root. She can delete Bill whenever she wants to. But anyway, so, but there was the Lewinsky affair at the same time, come on, so you know that she would want to delete the guy. All right, so NCSA Mosaic, that was IBM. In 94, the Natural History Museum, which was just around the corner from Imperial College, also had its own page. That sort of started making the web less just something to do with computers, but it kind of moved outside the whole thing of this is just a geeky network. You can have now stuff that is cultural. And then you can have stuff, other computer uses. Here, this is the joint network team at doing brain imaging. It's an academic institution. And they were basically putting brain imaging things on there, and you can see like 3D images can be manipulated in real time, blah, blah, blah. Uses a supercomputer. These days you can do it on your iPad, but back then it was a supercomputer. And you can see that was a big revolution. For me, certainly, and for the people around me who were like, wow, this stuff can be non-commercially used for non-commercial purposes as well. Now is the stuff that nobody ever tells you about, the internet timeline that it happened from the early 90s all the way to today. And it went very, very, very quickly. First you had some web browsers. Whoops, what happened there? Here we go. First you had the web browser Netscape. So NCSA Mosaic, as I said, were students in University of Urbana-Champaign, in University of Illinois in Urbana-Champaign. What happens with students? They graduate. What happens when they graduate? Do they remain in university? No. They get offered jobs, or they do what's called, back then you didn't know what it was called, a startup. Why don't we do this web browser thing? Why don't we make it commercial? And so they started a company called Netscape. And that's where the first web browser, commercial web browser, was put together by the same people. At the same time, there was a whole problem about trying to find things on the internet, because now you didn't have just like 5 or 10 or 20 web pages. You had hundreds of them, maybe even thousands of them, and they were growing at a very fast pace. So the question was, how in the world are we going to be able to reference all this stuff? Javier?
You don't describe NCSA as a browser?
NCSA Mosaic, but that was non-commercial.
Oh, it's non-commercial.
Non-commercial. It wasn't a company. It was university. So.
Yeah, correct.
So, but it's the intellectual property thing, isn't it? I mean, the dean of university said, he was asked, should we patent this NCSA Mosaic thing? And the guy said, well, that's worthless. I mean, a web browser? Who's going to use that? There you go. So anyway, Netscape started. So you couldn't find information, and so some clever bot said, maybe we can have some kind of a machine that uses the hypertext transfer protocol, HTTP protocol, that will start crawling through all of the websites and indexing those and putting into a website so people can do a search on those websites. And that's how the web crawler started. Simple spider that would go from website to website to website and index everything. The problem was that there was absolutely no protocol to find out the quality of the pages that were there. It would just do everything. So when you do a search, you would get hundreds and hundreds of results, but none of them really relating to your search. It was a very basic text search. Yahoo in '95 had a slightly different outlook. They said, okay, so we're not going to have an automatic crawler, because that gives you crap in, crap out. What we're going to get is to have a bunch of people that are going to themselves go through websites. Maybe we can employ students. Maybe we can have interns, things like that. A lot of people that will go through web pages, or maybe we can ask people to submit their website to the Yahoo list, and we'll build the list. And the first Yahoo lists were just text lists that were sent regularly via Usenet. But as the list became longer, they said we need to make it searchable, and they made their first website, the Yahoo website. We had categories and subcategories and searches. It wasn't an automatic crawl. It was all humans that were running the things behind the show. The problem with this, of course, is that the net continued to grow at an accelerating pace. Much faster. So what do? Do you hire more people and more and more and more? I remember back in '97, I met up with the guys at Yahoo, not David Filo or Jerry Yang, but it was Yang and another guy, Randy Salem. And they were like, we're so excited, we signed our 100th employee. I was like, wow, you just do just searches? Yeah, this is so cool. 100 people we are now. And they were in this big warehouse, which was terrible in looking outside, but inside everybody could do their own cubicles, how they wanted it to be. One was in the military tent, and the other one was a circus, and so on. I thought, these people are crazy. They're completely insane. And when we spoke about expanding to the rest of the world, they turned around and said, okay, next year we're going to do Europe. Oh, no. Shall we do Europe or Asia? No, yeah, we'll do Europe next year, and we'll do Asia and the rest of the world the year after. And I left the place and thought, these people are completely insane. I mean, come on, 2 years to go worldwide. Madness. But anyway, Yahoo did grow very, very fast, and eventually they introduced also the automatic search engine so that they could reference more sites. Alta Vista was a venture from Digital Equipment Corporation. Remember those good old boys at DEC that supplied the computers? It's only in '95 that they thought, maybe we can use the power of the computers that we have ourselves to do the searches and do the crawling and then do some kind of analysis so as to make the searches better when people do their search on our website. And so Alta Vista was created. It was actually a good search engine. I really liked it. It died for a simple reason that DEC was sold a few years later to Compaq. Compaq was just a computer manufacturer and said, oh, this software crap, out of the way. But of course, as you know, Compaq also got sold. It got sold to HP. So basically, it's like company eats another company, kills all the good stuff, keeps all the crap. gets bought by another one because they got the wrong stuff out, and finally ends up with HP that is still making printers and still making all sorts of things, but is not involved with any services, unfortunately. AP. Ask Jeeves in the UK. So in UK we had our first search engine in 1996. And in 1998, Sergey Brin and what was the other guy's name? All right, wait. The two guys at Google said, hey, we're going to do something. The searching is one thing, the crawling is one thing, fair enough. But what's more important is actually finding the right information. And for this, we need analysis. And so they came up with this whole thing of having analytical tools that would actually start optimizing your search based on your prior search results, based on your interests, based on where you were, based on a whole lot of parameters which remain secret. But magically, when you did a search on Yahoo on one side, and on the other side on Alta Vista, or even Hotbot, what a bloody name, Hotbot. Hotbot was the Microsoft.
No, Hotmail.
No, there was Hotmail, but Hotbot was before Hotmail. Hotmail and Hotbot was the one that was doing the crawls for, it was a search engine. And so you would do searches on each one of these search engines, and for some reason Google gave you the best results, and the other ones were giving you okay results, but not that great. Not only that, Google would answer, bang, like this. The other ones might take 10 seconds to respond. You're like, darn, I'm just going to go for Google. And this is how Google swept everyone out very, very quickly. They had the right model. And that actually was a first lesson, as in on the internet, don't think that customers are going to remain with you. They might just jump ship, and in a few months you go from there all the way down to zero, very, very quickly. In 2005, just to cut another few years down, YouTube was launched. That was actually, YouTube was originally not Google owned. It was a totally different organization that started. Then they sold themselves to YouTube. You know, the usual thing. You do a startup and you say your exit strategy is in 2 years' time we want to sell to someone that's got a lot of money and we can go to the Caribbean. We can move to Puerto Rico and take it easy. You know, we can have mojito, we can do all that. We can do all this stuff and someone else will run it for us, but we'll be rich by then. And that's pretty much what happened with YouTube. Let's go, talking about Caribbean, let's go a little bit back in '93 and see who was connected where. So throughout the '90s I was doing some research into tracking how the internet was growing around the world. And so this is the internet back in 1993. So the countries that are in green only had UUCP, which is, you know, the Usenet network, the dial-up stuff. So there was no web services, or it was just like email communication. The ones which were in this color, which is sort of cream color, had no connectivity at all. The ones which are in this color are in the other regions, so never mind those. But the ones that had full internet connectivity were the ones with the yellow and red checkers, and that's Costa Rica and Puerto Rico. Yay! Already, University of Puerto Rico was the first node, and it was back in, it's actually like 91, 92 is when they had their first connection. So when I did that map, it was back then, because I did this in 97. Ugh. Back a long time ago. 20 years ago. God, I can't believe this. So yeah, and Costa Rica was really advanced as well, you know. So they had CRNet. They actually implemented a network across Costa Rica and educational network as well. You move 3 years later and look at that, bang! Everyone's on the net. Now that's how quickly it went. 93, 97. So in these few years, we went from no connection to full connection across all of the region, except maybe a few of these places here. One of the reasons why it went so quickly actually is because many of the transatlantic fiber lines land in the Caribbean. Cable and wireless was particularly strong in this part of the world. I think there was in Anguilla or someplace around here they had a cable that came, and then to go to the US they would just go from island to island and then go up. So once you got fiber, you can have good quality internet very quickly, and that's how quickly it went. Satellite was another way, but one of the things with satellite is that you get this delay because your signal has to go from Earth all the way up into space and then all the way back down, and delay is not very good, especially when you have like movements and delay. For video traffic, for high bandwidth services, you prefer having a fiber cable, which is also more reliable because once you've laid it, it stays there. You send a satellite to space, Do you know that after 7 years, the bloody thing falls back on you? It's only 7 years. So you spend $100 million to send the thing out with all the dangers of blowing the rocket up and I don't know what, and insuring it and all this. It gets in there, it works or doesn't work, sometimes it doesn't work, and then 7 years later, it's run out of fuel to keep in geostationary orbit, and it starts coming back down, and you have to send another one. It's a money drain. It's crazy. The fiber you can spend, you spend your millions to lay it, but once it's there, it goes on. So that's how Central America was well connected.
I know the lifetime of a usual the lifetime of a usual submarine cable used to be set at 25 years. But now with fiber, they don't even know what the length of time of life it has, so it's very interesting.
So it's not bad, is it? You lay it and except if some idiot with their anchor,
No, it's the sharks that bite.
It's the sharks that bite it. But the sharks used to bite it. That's a good point you made. The sharks used to bite it due to the electromagnetic radiation.
True.
But now that it's fiber, I don't know if sharks get high on light, but I don't think they do.
Exactly. That's why they don't know the length now, because they're...
That's why they don't. The other problem with cables, with submarine cables, is although charts, marine charts around the world show exactly where the cables are, you occasionally have some idiot, the captain that's been drinking too much, that decides to throw the anchor right there, and then they pull, they go, it doesn't go, it's stuck, pull it harder, and you're laughing, but it happens, and it cuts the cable. And so there have been some cases of this happening in some parts of the world. In fact, in Asia, there was such a case where a whole region had internet slowing down by a lot for a matter of like 4 to 5 weeks, because what happens, you need to send a boat over there and divers and pull the cable out and put it all back together and put it back in. So it takes a little while to fix, but it's certainly less expensive than calling NASA and saying, when is your next shuttle so we can go and repair a satellite in space? And in fact, now there's no shuttle, so you're stuck basically. It's broken, in the bin, and build a new one. So with all of these new people on the net and so many more computers, you'll no doubt hear about IPv6. Now it's again Internet Protocol, but it's just the addressing part of the Internet Protocol is a lot longer than it used to be, because those, the normal IPv4 addresses, which is like 3 numbers from 1 to 254, dot 1 to 254, dot and dot, so 4 sets of 3 numbers. That is getting very crowded now, and we've kind of run out of addresses, so we need more for all of these Internet of Things devices, all these new things coming up. So IPv6 was given there, and nobody knows really how big IPv6 space is. You can see here, this is the number of IPv6 addresses that are possible, so that's a lot of addresses. IPv4 looked really big back, at the beginning. But seeing that now we all have more than one mobile phone, and there's like, I don't know how many billion people on the planet, I've not lost track of that, and how many billion of internet users. I mean, initially, I remember it's like 1.5 billion users, 1.8 billion, 1.9 billion, 2 billion, 2.1, I don't know how many billion now, but it's a lot more people that are on there with more than one device, so you need that space. And if this is a dot with the IPv4 space, this is the sort of space that you might have with IPv6. So hopefully, and I'm not saying this should be enough for everyone, because Bill Gates once said 640K should be enough memory for anybody. So he was wrong. And Vint Cerf and Bob Kahn said, hey, IPv4, we put these addresses like, this number here, this thing should be enough addresses for everyone. And they were wrong. Yes, they were wrong too. So I'm not going to be wrong. I'll say it might be.
I was just in Monterey at the seating conference with Vint, and he told a story about how they developed this number. And they said, okay, so our country has a couple of networks. So we have military and we have our thing. And then, so if you figure there's, I don't know, 130, 150 countries, and they each have 2 networks, that would be, 250, 260. So 4 million should be plenty.
Yeah.
That's how they came up with it when they were working on it.
That's always the thing. You do a quick calculation because you're pressed for time. So the internet was really designed on the back of an envelope, to put it this way. But that was basically it. Okay, how many should we do? More. One of the problems is if you have longer addresses, then when you transmit this via the network, then every packet that you transmit has a longer address. So then it becomes less efficient, because you've got your address part and you've got the payload. The payload is the actual information you want to send through. The address is the addressing. Longer addresses means less payload. And so back then, because the network transfers were so slow, you were talking slow speeds, they said, let's keep it to a manageable size. Now, of course, we transfer things a lot faster so we can have an address space that is a lot larger than it used to be before. The internet continued to grow, and as you know, we spoke about these submarine cables. There's not just one, there's some all over the place. You can see here how crowded this part of the world is. But here also, North America and around Hawaii as well, and here in Asia is just insane. I mean, South China Sea, I don't know. It's like, if you're ever over there and you're sailing, do not throw the anchor overboard. You might be in deep trouble. And then eventually it became this. So this is like the physical infrastructure from, that was like 1999. So imagine now there's even more of this in there. And now you've got this stuff, which is, you can't see very well, but that was like internet routing in 2002. And then it became like a heat map of how much internet traffic there is around the world. And that was like, that's social networking. So you look on a different layer and say how people are connected to each other and how many users there are. And this was the Facebook heat map. You can see it's very, Facebook, I don't know where that company is, but it seems to be very busy around that part of the world and over here. That, as we know, is like close to Russia, and this is, I don't know, North America, something like that. Anyway, very busy parts of the world. And so you end up, again, to the thing of how did it all come together, and it came together with one thing. Any type of traffic being allowed, the end user principle, the whole champion for innovation. You've got an idea, you've got a service that you would like to put on the internet, and you can do it. You just need to get an account with your internet service provider, or you get some hosting space in one of the clouds, and bang, you can start your service. You don't need to ask your administration if you need to, if you can do it. You don't need a license, you don't need any of this stuff. So any small company can become absolutely huge. And so people like in Snap, for example, you know Snap, don't you? The history of Snap, Snapchat, all this. So these guys were like 10 people in the office. They 10 friends. They came together. They started putting together this service, which was like a quick chat system that was faster than Facebook, that was much more lean. So when you put it on as an app on your mobile, it goes really quickly. It's easy. It's fun. And then it suddenly picked up because everybody wanted to use Snap. It's a lot easier, Snapchat and stuff, than using the other services out there. And within, I think it's like 19 months or something, Facebook looked at them and went, maybe we should buy those guys. And they bought them for over $1 billion or something. And it's like, it's madness. And you think, why did they buy them? And it's more like, the big companies now buy you because they don't want you to become a rival of theirs, because they learned the history. Was it Snap or was it the other? Instagram. That's the one.
Actually, Snapchat, the guy that created Snapchat has a big riff with Zuckerberg, and he doesn't want.
He doesn't. Okay. So
Zuckerberg
Snap was the independent. It was Instagram. Sorry. Okay, my mistake. All right, that's the first mistake out of many other mistakes. So check where the other ones are. Anyway, they became really big very quickly. Instagram, and you think like, how easy was that? How easy was that to manufacture or to put together? But really, it's just the big boys didn't want them to rival them, so they bought them over. And there are quite a few stories of companies like this that came out with great ideas and then they got bought over. Now, internet is changing the business world. As we know, a few years ago, it was really important to focus on this. I think that we're all convinced about that. You've seen all of that going on, iTunes, open source software. Facebook back then, this is an old slide, 500 million users. I don't even know how many million users Facebook has today. Is it like billion or something? How many?
I think it's more than 1 billion.
More than 1 billion. How many of these are real? How many of these are phantoms? How many users are dead?
600 million are in Russia.
600 million are Russians, yeah, Russian bots. So anyway, you've got all these things, you know that, and you can see in actually some of the traditional industries and traditional audiovisual industries what it did to the world. If you look at the world of CDs and music sales, so this was back in the sort of 1970s. This is actually supposed to be like one long thing. So it starts with the left, and then it continues with the right. It's a time continuum for the oldest part of this side to the newer stuff on the right-hand side. And you can see that there was always a sort of lifetime for each one of the formats that were used. So 8 tracks was used all the way until the end of the 70s or mid-70s. That was replaced by the cassette tape. Micro cassette tape. Remember this? Anybody remembers this stuff?
We got tons of them.
You've got tons of these. Can you play them anymore?
Yeah, we still have boomboxes that have cassette tape.
Oh, you have one of the big ghetto blaster
I
type things.
actually have a thing that's a dual device where it takes cassette tape and puts it on CD.
Right on.
Yeah.
The whole thing, you know, you get Rapper's Delight, 1981,
exactly.
or 1979, sorry, and Grandmaster Flash and the Furious 5, and it's all on micro cassettes, because they weren't going to take records with them over to the city. So breakdance all started on micro cassette tapes. But you can see that as time went on, that fizzled, because you ended up, and the LPs, so these were like the vinyl discs.
Come back.
They're always coming back. You know, the old stuff always comes back when people suddenly go like, oh, what is that? This is so cool. And it sounds so good. No, it doesn't sound so good. Oh, but you know, it's more pure. It's the original stuff, you know. I can hear Louis Armstrong so much better on one of these. No, you can't. Digitally enhanced Louis Armstrong is a lot better than the crackle of like, anyway. LPs are still there, of course. There's still aficionados.
I disagree.
Of course, I disagree too. I've got one of these super hip things, you know, that I bought in sort of, I think, mid-90s. Dual 505 Mark III with crystal pointer that goes on the disc, and I don't know what, you can set 1 gram, 2 gram, 3 grams on your disc and all that stuff. I still never use it because it's a bloody pain. And it's in storage. It's been in storage for 10 years. So I'll take it out one day when I have time, you know, it's like, and I'll buy a few LPs to support the cause. But all of that, you know, fizzled out effectively very quickly. Cassette tapes came there, and what you don't see is that this was right behind, and all of that was replaced effectively by the CD. And you can see the peak year was in 1999. Prince, 2000, party over, out of time, 1999. That's when the party was really big for the CDs. And then it died. And why did it die? Because these guys started here. Remember the YouTubers and the SoundClouds and all of these that started up? They very quickly started growing at such a rate. Here, of course, we're still, you know, 2008. This is really taken over, basically. And so your CD sales and your LP sales and your DVD sales have completely fizzled away. You can see here a Boston Consulting Group study in 2011 was showing a growth in the IT industry and ICT industry of 10% a year, 7.2% of UK GDP. And if you compare this with the other UK sectors in 2009, real estate, partly because of London, because getting a property in London is totally impossible. You know, a toilet costs you $200,000. So real estate and business services was 23, manufacturing was 12, wholesale and retail 11, financial services, the city in London was 9, and immediately here you get internet. So internet is actually was generating more income than health and social work, but it was more of a turnover than that. So you can see how this is growing. And it's grown a lot more even since then now, and it's the same in most countries, and at least most Western countries. And that's where you'll see there's a political discrepancy between those countries that don't like the internet and see it as a threat, and those countries that like the internet and see it as an opportunity for business. And that's one of the major discussions I think we'll probably have in the next few days. Politics, yeah. Do you remember this? So here, this is the flag of Egypt. And this is what happened on January 27th. January 27th, Tariq Kamal, who then was the Minister for Communication in Egypt, got a knock on his door. Now, if you don't remember this, so this was over the Egyptian revolution. You know, all these guys went over to Tahrir Square and said, we want Mubarak out of our country, and the guy is an a-hole, you know, bad person. But they were using terrible words at the time. And they basically rioted and wanted these people out. And a lot of people in Egypt, of course, like everywhere, you know, everybody has mobile phones, everybody's got internet, and they were following what was going on remotely. On the morning of January the 27th, and this is Tariq who told me himself, because now he works for ICANN, he had a knock on the door, and it was the security services of Egypt that turned up, and they said, right, sir, we have to turn this internet thing off, because this is spreading fake news, bad news around and stuff about what's going on. We need to cut this right now. Come with us. So they went to a place called Ramses Street, which is in the center of Cairo, not very far from Zamalek. this central telephone exchange. They went to one of the rooms, and there was like, it's not a switch, but it's like a rack of equipments and so on. And all you have to do was to basically turn the whole rack off, and that's it, Egypt was off. And you can see how quickly the traffic went down. That was at 6 p.m. Well, it was picked up in the morning, but it takes a little while to go across. Anybody being in Cairo can see there's so much traffic. It takes a little while. Anyway, at 6 p.m., the traffic went off, and it remained off for a long time. The effect was actually the exact opposite than what they thought, because since nobody could access what was going on their phones and on the internet, they decided to go and check it out for themselves. So by 7:30 p.m., the whole place, the whole of Cairo was absolutely overwhelmed with people, and the rest is history. So as a government, and as an organization that you deal with the internet, sometimes you have this thing of saying, well, let's just cut ourselves off when there's something that goes wrong, but what you're doing is like, you're not really safe, because what you're doing is to cut your own branch. And that's one of the things I like to do regarding legislation. If you start legislating too much, what you really are doing is to hurt your own self. But you've got your safety line, it's just attached to the wrong part of your body. Now, who talks about all this technological achievement and everything having moved from, the 2 nodes that we had to start with? As you can see, we've now dealt with politics, we now dealt with business, and then the lawyers come in, and the politicians come in and say, but wait a minute, this stuff is run by technologists. These guys have no idea. We need to put rules and regulations on this stuff. I mean, this is ridiculous. Engineers that tell us what we can put and not put on the internet. What about this criminals, and what about all of these bad people, the terrorists and pedophiles, and no, and people can express what they want to say. No, we don't want that. We want some kind of a regulation. Let's put rules. And this is where you ended up with a thing called internet governance. As usual, and this is a great diagram from Diplo, internet governance was a sort of term employed to show a whole number of things taking place in various component parts of the internet that included both the sort of cultural issues, but also some of the technical issues, some of the legal issues, legislation, etc. In the books, one might tell you, yes, this was all set up through this process, and this meeting, and that meeting. In the reality, it was absolute chaos. And because everyone came into this very quickly, it came up to some kind of a chaotic construction site with all of the different component parts coming together, and maybe putting together something that didn't quite hold too well. So that was this sort of early days. But Diplo then came up with something a little bit more updated a few years later, and that looked a lot cleaner, with cybersecurity, development, economic issues, socio-cultural issues, human rights, the well-known network neutrality on this side, and the whole thing of saying, well, it's digital governance, internet governance, cyber governance, something relating to governing this whole system. And the great thing about it is that it's not just built by one organization. It's like everyone is invited to come into this, to build it as a piece of the puzzle. Because the main thing about the internet is that its whole governance system is multi-stakeholder. More than one stakeholder is taking part. Anybody interested in taking part are invited to take part in whatever capacity they can take part in. So if you look at the whole overall internet governance ecosystem, there are hundreds and hundreds of organizations, companies, civil society, governments that have come together at various degrees. And I'm not going to go through the whole list, but you can see well-known names like Apple and registries and registrars like Affiliates, and user organizations, and think tanks, and all that being involved. The Internet Society has put a slightly easier diagram together that shows the different stakeholders. So you've got naming and addressing with freely accessible process for policy development, local, national, regional, and global policy development, educational and capacity building, users at the bottom, shared global services and operations, and open standards development. And that's where the IETF and the World Wide Web Foundation, World Wide Web Consortium come. We'll touch on these in a moment. And that's the sort of internet ecosystem as such, as developed by or as shown by the Internet Society. And now, since we're talking about the Internet Society, who the heck are these guys? So ISOC Puerto Rico is very involved in this part of the world. Yes, Eduardo? No? It's all there, right? Internet Society in itself was founded in the early 90s, 1992. And guess who was one of the founding members of this? A gentleman by the name of Vint Cerf. Yeah, the same guy again, the father of the internet, the father of the Internet Society. And it was basically put together as an organization that was supposed to, it's not for profit, and is there to kind of defend the internet model and help out with the development of the internet and teach people about the internet, both on the technical side, but also on the societal side. So speak with all sorts of stakeholders, academics, to try and build some support for the internet model. Because remember, back in '92, nobody really knew what the heck this thing was about. It also acts, and this is important, it acts as the legal home for the Internet Engineering Task Force, because as you know, any meeting requires money, sponsors, this sort of thing, and of course something legal, because if you do it as an individual, you end up being sued if somebody breaks a leg or whatever. So, legal home for the Internet Engineering Task Force. The vision of the...
Could you explain a little bit what the IETF is?
It's coming in a second. Ah! You're always 3 slides ahead, Javier. So, remember, there's 99 slides. We're only at number 12. So, I don't even know how many hours I've got, or have I already finished an hour and a half ago or something? Oh, it's 3 p.m. Okay. The internet is for everyone. So, the mission, as I said, promote the open development, evolution, and use of the internet for the benefit of all the people around the world. It's a good mission. It's got chapters that are based all around the place. So these are independent organizations run by volunteers that subscribe to the Internet Society core values and that have become a chapter through a sort of a registration process and have local meetings, and they help out with schools of internet governance apparently and this sort of stuff. But there's more than 85 chapters. In fact, I think now it's more like 100 and something chapters around the world. Here we go, 129 chapters around the world, 157 organizational members, and more than 100,000 members and supporters. The Internet Society is, as I said, so the umbrella for the 2 organizations. So you've got the Internet Engineering Task Force, that is a large group of people that are either sent by their companies or by their university, or even independent, by their own selves, going to an IETF meeting, taking part in the work that takes place. Most of the work takes place in working groups that have a mailing list, so most of it is on mailing lists and conference calls and things, and then they meet a few times throughout the year, all in the same room, along the different projects that they're working on. And you've got next to it the Internet Architecture Board that is, again, part of this whole Internet Engineering Task Force that effectively sets out the basic lines as to which directions, which areas of work should be focused on. So you've got management of the protocol, parameter registries, and management of all of the other services. And we're talking about the actual, the Internet's entrails. So what I mean by that is TCP/IP, some of the services like email, but the web stuff, for example, and the presentation part of the web is not dealt with by the IETF. The cybersecurity part, yeah, these guys are involved with it. We've got several cybersecurity working groups on encryption of emails, encryption of the DNS, all of this. This is all done in the IETF. You can recognize an IETF person by the fact that they're not wearing a tie, apart from one person who is allowed to wear a tie, and that's Vint Cerf. My first IETF meeting that I went to physically was in Dublin a few years ago, and I turned up like this. And I was nearly kicked out of the room. The meeting did stop. I arrived late and they just turned around and went, "Who the heck is this guy? Is that like the tax inspector or something?" They were really worried. And so in effect, Vint is allowed to wear his 3-piece suit and all this stuff. Everyone else wears t-shirts. And of course, the next day I was wearing a t-shirt. Now, you've got organizations. So Internet Society was just an organization that kind of helps with the whole internet and promotes the internet. The other organizations that you're going to see now are actual operational organizations that actually have a stake in running parts of the internet. First is ICANN. So that's an organization that was set in the late 90s to take over the work of the coordination of the internet's identifiers, so IP addresses and top-level domains, from the US government, because as I mentioned an hour ago, nick.ddn.mil was the US military that was doing all this updating of tables. Then they got this guy called John Postel at the Information Sciences Institute at UCSD, I think it was? USC, sorry, yeah, University of Southern California, that's it. At USC, and he basically was giving out IP addresses. You just needed to email the guy and say, hey, I've got your network. And I remember doing this, emailing him and saying, oh, what do you want? Class A, Class B, Class C. Class A was the biggest allocation you could get. I was an idiot. I said I want the smallest allocation. I should have had the biggest because then you can resell it. Hey, you know, fair enough. And that was it. But of course, as you then ended up with thousands of networks daily, you needed an actual organization to do this. And so that's how they said, okay, ICANN is going to be coordinating the top level of this stuff. What it does also is to develop policies that are developed in a bottom-up fashion, so the different ICANN component organizations and parts of ICANN and communities have to work together to design tomorrow's internet addressing system. And there's an ICANN meeting here, so I hope that you're able to stay and see how crazy the circus is in that place over there. But people tend to get very heated and very excited about issues. And it's... yeah, it looks easy on paper, but really, in reality, it's a lot of consensus building. Is a lot of pushing and pulling. Top-level domain. So this is what it is. .org, for example, is the top-level domain for those people that don't know. And this is the second-level domain, and this is the third-level domain. So the important thing for ICANN is that it only deals with the top-level domain. Underneath that is run by the respective registries running each one of the top-level domains. ICANN has got many functions. I think this diagram best checks what it does. So you've got on the one side these generic top-level domains that have policy that is being developed for them. And then you've got, so the policy is at the heart of it all. There's 182 million of these domain names. And then you've got this lookup that goes and that translates from the domain names over to the addresses. Yes?
BN?
Billion.
Oh, just billion.
Hundreds of
Okay.
billions. Yeah, it should have been in lowercase. I don't know. I must have. It's true, actually. Yeah. Nobody's ever asked this one. Probably by now everyone was sleeping or something. So I'll change that to a small n. And then you've got generic on one side and then country code top-level domains on the other. The difference between the two is that the generic top-level domains have a contract. The operators have a contract with ICANN and need to follow ICANN rules. So all of the policy and rules regarding the running of these domains are developed within ICANN. The country code ones, and here we could put .pr or Puerto Rico, are completely independent. So if they want to have their own rules that are very restrictive on who is allowed to register a domain name under .pr, or rules regarding intellectual property or cyber criminality or whatever, they can do whatever they want. And in fact, some of the country code top-level domain operators are not even an ICANN member. They don't even want to have anything to do with ICANN, but ICANN still carries that in the root because it's as part of, they have to allow for these country code operators to be there. Some of them are really involved. There's various levels, and so they're involved in the CCNSO, Country Code Name Supporting Organization. And then you've got the protocol and parameters. There's about 1,000 of these. And you got over 1 billion IP addresses. And of course, this was still with IPv4. Now you've got IPv6 that's there as well. We talked about the root servers. So the root servers are the A root is actually the center of the domain name system, which is the place where .edu, .org, all the top-level domains are located. And there are copies of this one. So there's the A root, and then you've got copies of it that go all around, there you go, that are in various different countries around the world. And this is all quite historical. So the A1 is actually run by a company called VeriSign. Until a few years ago, it was the US government that was giving it its instructions. So ICANN was developing the policy for the domain names, and then the updates would go through a part of ICANN called IANA. And IANA would pass on this requests for changes over to VeriSign, but the US government would have to give its green tick for this. A process called the IANA stewardship transition happened a couple of years ago. got us, a lot of us, to lose a lot of hair and make a lot of gray hair and get really frustrated. And we ended up with transferring this responsibility of stewarding the process to make sure it's all done correctly to the ICANN community, and make sure that there are checks and balances. So if ICANN ever goes rogue one day or something goes wrong, there is a way to actually save the internet, and the internet can continue to work without ICANN existing or some redress being done. So the stewardship transition and the accountability part process, which initially we thought was going to be 1 year for stewardship transition and 1 year for accountability, ended up dragging on and costing a heck of a lot more than it was supposed to cost initially. But that's the nature of multi-stakeholder systems and of consensus building.
And IANA stands for?
Internet Assigned Numbers
Agency.
Agency. Yeah. It used to be like before. Now it's changed as well. Now it's PTI. So PTI was post-transition IANA when we were working on it.
Technical identifiers.
The original name was that.
Original name was post-transition IANA, and then they said everyone knows it by PTI, so let's find another name. And it's like moving backwards, trying to find something cheesy to work it with. Anyway, so these are the root servers. They're actually totally independent. So, okay, so the A root is supposed to follow the instructions of ICANN, but the other ones could follow anybody. If they decided that the A root is not what they want to follow and they want to go and build something else that cuts ICANN out, they have the choice to actually go and move on and follow another naming system. Maybe one of the other ones can make them the authoritative root. This is one of the things. There's a relation of trust between all of these different root operators. There's no actual contract that binds them together and says, if you don't follow this, we will sue you. There is no such thing. This is why when there's this whole debate about ICANN runs the world, ICANN is the authority, the Russians don't like ICANN, the Chinese want to make their own ICANN, and so on. Actually, even without all of the contracts and all this stuff, the whole thing is ICANN currently runs it because everyone, or the majority of people outside, have a trust that it's run correctly. Because what do people want? They just want an internet that works. And so far, the internet has worked very well with this. In fact, there's a lot more than just these operators. Many of these copies of the root, many of these have got hundreds of other sub-copies with their own organization. VeriSign, for example, has got copies that they have throughout most of Europe. There's some copies in Eastern Europe as well, and Asia, in many different places. So what you end up is hundreds and there are copies here? The L root. So who's L? Who's L? Internet. Oh, ICANN. So you've got a copy of an ICANN root here. There you go. So even if the Puerto Rican network gets cut off momentarily by a problem, the names will still resolve internally because the root will still serve. So the local root will still work. It makes it for a very resilient network.
We have 2 copies of L.
2 copies of L. Oh, yeah.
L here, and I believe the critical hub has a copy of J.
Of J as well. So you can imagine. So J is from VeriSign. Yeah. Yeah. So it's very resilient, very reliable. It works pretty well. And as I said, it's all a building of trust. So this could change one day, but so far, it's worked really well. Now you've got the regional internet registries. They're very important. They're the people that distribute IP addresses. So IANA, and ICANN have got this overall registry with the whole number space, and this needs to be allocated. And so 5 different regions are present. And each one of those 5 regions, as you can see here, have a regional internet registry. ARIN for North America, LACNIC. I think is here. Are you guys in Puerto Rico with LACNIC or with ARIN? ARIN, yeah, because it's part of US. So okay, so ARIN is distributing the IP addresses. Here you go, AFRINIC, RIPE, and APNIC. And again, this is all just historical. Some of these organizations started before the others, but each one of them is semi-independent, and they all are known as the ISTAR organizations. So ISTAR organizations like ICANN, ISOC as being the people that do all this evangelism about it, and the regional internet registries. And it's funny because you'll find out in ICANN there's you can see NRO, Number Resource Organization, and ASO, Address Support Organization. I've never really understood so much the difference between NRO and ASO. The ASO part is more the ICANN part, like you've got the GNSO, Generic Name Support Organization, and you've got the Address Support Organization. The NRO is more like the grouping of those different regional internet registries that all take part in the ICANN processes. You'll learn more, I think, later on this week when we dig a little bit more on these. You've also got regional organizations that deal with domain names. And so a center, for example, is the one for country code registries in Europe. You've got LACTLD, AFTLD, APTLD. Is there one in North America? I was trying to look for. There isn't really, is there? Because there's only 2 or 3 TLDs in North America, or country code top-level domains. You've got .us, .ca, .pr, .mx maybe, but according to your president, they don't think that it's part of North America. So, no, your president. Javier.
Pablo, correct me if I'm wrong. .pr is in LACTLD.
No.
No, it's not.
North America.
Oh, really?
We're North America.
North
North
America.
America you have, that US,
Well, what about
or
now?
in geographical order would be Canada,
Yep.
that CA, that US, then it would be Puerto Rico, US Virgin Islands, that
Ah, as
BI.
well.
Then we have Guam.
Of course.
Then we have American Samoa.
And then Northern Mariana Islands.
And then North Mariana
Who
Islands.
is it?
And these are all far out in the Pacific.
And they are
Yeah.
all given to Navarro.
For and all part of Navarro. Great. So you haven't gone to Guam yet, have you? It's a military base. All right. Back to this. Back to this thing. We're starting to take more time than expected. The World Wide Web Consortium. Who the heck are these guys? Well, Tim Berners-Lee. Do you remember him? The inventor of the World Wide Web. He started out an organization that is the World Wide Web Consortium that is there to develop the standards of the HTML. Because of course, there was version 1 when he started it up, but then after that it kept on, on evolving, and so HTML standards keep on being developed by these guys. They've got full-time staff, and yeah, they have a mission to lead the web to its full potential. There are other organizations, the ITU being one of them. The ITU is the International Telecommunication Union. And yeah, we shouldn't talk about the ITU, should we? No, let's talk about the ITU. ITU raises a shiver in some people's mind, going, oh my God, the big bad ITU. And they're not, they're really great. I mean, I think, first thing, they've been established in 1865, way before the internet. And they were an organization that was put together to deal with billing of telephone systems. Because first telephone systems were implemented back in those days, and immediately the first thing was, well, who pays for what? When I call someone in the same country, it's fine as one operator. When I call someone and another operator, there's going to be somewhere a mix between the two, and how in the world are we going to be able to share the revenues? And before, when your country was connected to 5 different countries, then you needed to have 5 different commercial agreements to each one of those other countries and different profit-sharing systems. The problem, of course, is as more and more countries started getting telephonic services or even telegraphic services, it became more and more complex. So yet again, they thought one organization is going to be able to deal with all of this billing system, and that's how they started. Quickly enough, they moved over to standards because, hey, if you've got one organization that is in touch with all of the different operators, then maybe that organization can also harmonize the standards, and you started having all sorts of series of standards. And you know, one has to admit, all of this thing about modems back in those days, and so on, they were very strong in that. They were very strong in all the physical infrastructure. They were very strong in the spectrum, allocation of spectrum, things like this. But the internet is something that they completely bypassed for one single reason. And that's me saying it, by the way, so don't take my word for it. But my feeling is that one single reason. At the time, they had developed the X25 protocol for sending packets, you know, and sending information along. TCP/IP was not something that was developed within the ITU. And so they looked at this as being some hobbyist crap network. I'm using the word crap again. CRAP, the acronym, of course, which you'll have to work out. But something is not being very good. And they thought, you know what, this thing has no chance. We're going to stick to the X25. And because the internet doesn't use X25, because we have something better than that, like email using X400. X400 addressing, by the way, is a nightmare. You have to say the administration code and the, like you have to give, your email address is about 100 characters long. Yeah, it's really big. And if you make one mistake in there, the whole thing crashes and says unrecognized. You have to start again, and it's just unusable. They thought that this was the future all the way until the early 90s. It's only when the World Wide Web picked up that they felt, okay, we really have lost this one. And it took them quite a while to recover and to actually think, okay, how can we get back in the game? To this day, they really still haven't gotten back in the game because other organizations like the IETF deal with the standards. So there's no real need for standards writing in the ITU. Plus the fact that if any of you have followed the standards development in the ITU, you will have found that to develop one standard, it takes 4 years, 8 years, maybe 12 years. It takes a long time. And by that time, the internet would have changed very quickly. So it runs at a different pace. It's got a structure with the radio, ITU-R, the technical side and the development side. These are the different things. And you can see here, Telecommunication Standard Assembly, WTSA, Telecommunication Development Conference, WTDC. All of these are conferences that take place on a regular basis every year. And some of the threats to the internet, threats as in, this organization, members wanting to get involved with internet development in a more top-down way than the bottom-up multi-stakeholder way that there is, comes from WTSA and WTDC that then feeds into the ITU Plenipotentiary Conference every few years. There's ITU regions. You can see it's all, remember, ITU is actually just all countries. They have sector members, so commercial organizations and academia that do not have a vote at the end of the day. The only people that have the vote are the member organizations, the member countries. One vote per country. And as you know, because this is very much like the UN system, you can do bartering of votes and trading of votes and stuff, and you say yes to this and we say yes to that, and it becomes extremely political. And unfortunately, many of the ITU conferences are just so political and don't focus on the actual topic itself. The telecom regulations went through a process where in 1988 there was a treaty, and we're still running on that 1998 treaty. Some of the stuff in there is really good, but it's completely out of date because in '88 there wasn't the internet that we have today, and certainly the World Wide Web did not exist. So back in 2012, there was a process. It took so much time to prepare for that conference that took place in Dubai. So we'll come back to that in a second with the ITRs. But in 2012, there was a process in Dubai, and it ended up not with the desired results at the end of the day. So you got regulations, you got the WTPF that I spoke about a moment ago, WTDC, a 4-year conference. It's an enormous amount of conferences, lots of paperwork, slow process. A lot of the stuff is on general broadband, on ICTs, information and communication technologies, not focusing specifically on the internet. A lot of educational side to it, and the ITU is doing an enormous amount of good work actually for this, to teach people about ICTs, how to use computers, how to connect devices, and so on. There's the Plenipotentiary Conference, the last one being there was Busan, and then there's another one coming up.
In Dubai.
Is it in Dubai? Yes, this year. It's this year, isn't it, in Dubai? Yep.
Right after the ICANN meeting.
Right after the ICANN meeting, so that's another one. And it's important for ICANN because it started, the one in Busan started addressing internet issues, and increasingly so. Governments are starting to think, wait a minute, why don't we run this thing? This is run by these organizations that we don't know about, that are self-appointed or have self-appointed themselves over the years, or worse still, that are appointed by the evil America. And we don't want the evil America to appoint these organizations because the evil America still runs the internet. It's an American network. We want this to be completely independent. And so now we're going into just politics and geopolitics rather than dealing with a network that is supposed to serve the world, you know. Many United Nations processes also taking place. The CSTD, Commission on Science and Technology for Development, had a year-long or year-and-a-half-long process right now to try and redefine what it was doing. It reached no consensus.
No, it was 4 years. I'll talk about it.
Was it a 4-year thing?
It was tough. I'll talk about it.
Okay, Judith will talk to you about that. It was failure, though. I mean, it was
Twice.
Twice. There you go. So twice it went, it met, it spent an enormous amount of
That's
time.
just the working group.
It's a working group, yeah, but the whole over CSTD thing is quite a history. You'll deal with it, have fun with that. UNESCO is also dealing with this. Many different organizations are now looking at internet governance.
I'm going to cover this.
Judith will cover this as well, the WSIS plus 10 review, so I can move on. And so you end up with basically an enormous amount of geopolitics and governance discussions. The IGF is one of those places that offers a multi-stakeholder environment for people to be able to discuss internet governance issues. It meets every year. It was initiated as part of the World Summit on Information Systems in 2005.
I'm discussing this.
You'll do that as well, so I can move forward. That's good. It's excellent because, you know, that's like 2 hours shaved off. Internet and Jurisdiction is another self-started entity that has basically decided to look at some issues. It's not a formal organization like the ITU or like the UN processes or like ICANN, but they do some interesting work. They actually met in was it Toronto?
Ottawa.
Ottawa. They met in Ottawa just a couple of weeks ago. Was it last week?
Yeah.
Last week. I haven't had a chance to read what happened.
All view.
They discussed all sorts of things over there that related to some of the challenges that the internet faces today. So there were more, you know, the stuff that sometimes you call these orphan issues, issues which nobody really talks about. There's no real formal location where you can talk about these things. So they thought they can facilitate dialogues and stuff like that. And so they did quite well. The ecosystem, two major things. I think we've covered it somehow. Multi-stakeholder. So a multi-stakeholder environment is one where we've got this whole set of players that can talk together, and no one has precedence over the other. So there's this equal voice that you can have in the discussions and in the decisions as well. If you go into a multilateral environment, such as what's happening at the ITU, for example, or some of the UN processes, then governments speak to governments, businesses to business, civil society to civil society, and there's no real interaction between them. And at the end of the day, only the governments are the ones that are making the final decision. So you can talk as much as you want, nobody will listen when it comes down to taking the decision. Or they'll just say, yeah, whatever, and then take the decision as it is. And so that's something which doesn't work out too well in many environments. Why is multi-stakeholder better? Because when you get everyone in the room to actually work together to build a solution, adoption of that rule of this is a lot better, because everyone's already flagged the problems that they might have with the system that is being developed. And this is one of the reasons why the net is working, because so many different parts have already talked into building it. The problem with the top-down multilateral way of doing things is that you can have, you know, WCIT, the World Conference on International Telecommunications. They had really interesting standards. There was no consensus, and finally, none of the stuff was implemented because, well, you know, it's the politics continues after the decision is made. There's always, you know, in theory is the same as practice, but in practice it is not. And that's exactly the problem that you get. With multi-stakeholder systems, it might take a little longer time, but you end up with a solution that either satisfies everyone or that everyone hates. But at least there's consensus that everyone agrees with each other. Either everyone hates it or everyone loves it. So there's agreement, which is really good. Why is it important for internet users? Well, because ICANN is running in a multi-stakeholder environment and it needs to remain this way. Yeah, 1 minute, I think I've got 92. Look at that. Well, 92. This is not bad. And again, because it's so important that end users and that civil society and that corporations are able to put their input into this, because the whole system works as one piece, because it affects everyone in the same way. There's a fight between those two systems, multilateral and multi-stakeholder, and so the conference in Dubai, which took place in December a few years ago, ended up after, I think it was 3 weeks or 2.5 weeks of discussions with, contrary to what some people said, the US walked out. No, the US did not walk out. I was there. One country, namely Iran, put the flag up and said, okay, we're going back and forth. It's now been 4 hours that we've been discussing the issue of human rights. Mr. Chair, I'm sick of this. Let's just do a vote and be done with it. And the vote took place. And of course, with ITU processes, you need a unanimous vote. And of course, there was a split vote. I think 32 or 36 countries voted against the adoption of the regulations. And so you ended up with a 0 game at the end of the day. And many years later, we still have no implementation of these telecom regulations.
They're not needed to be implemented.
They're not needed, I know, they're not, well, that's a US-centric view, of course. Some would tell you they are needed, but different thing. Anyway, so calendar of key global events. I've got an old calendar of these. You can see it's one thing after another. This is why I travel so much. I don't go to all of them, thankfully, but many people are ending up going from one thing to another. It goes on and on and on. This was 2016. There was none made for 2017 because nobody even had the time to make the calendar. I've just seen one that somebody at ICANN made for 2018. So that's really good. At least we know where we're going to go, or physically going to travel to. Everything is changing so quickly, so don't be afraid of change. A lot of countries, and this might not be the case in this part of the world, but when I present this over in Eastern Europe, or in some parts of the world where society is more conservative, there's always a fear about change. Oh, but you know, the internet is here. I remember I did a thing in India about IPv6, and some person stood up and said, but we don't want IPv6 in India. I said, why don't you want IPv6 in India? I said, well, the internet is already so slow with IPv4. If you put more addresses, more people will go on it. It'll be even slower. So, you know, there's a fear always for something changing for the worse, and so you need to look at the opportunities more than the fear. And unfortunately, those countries that are not particularly democratic see the internet more as a threat than an opportunity. So, what needs to be done? Well, you've got your usual thing: get engaged with all of these issues, IPv6 and ICANN, ITF, and all that. Because if you don't, others will not, and if there's not enough people getting engaged in this stuff, then there's those people that are just paid bureaucrats to run their little tick-the-box day that will end up running the internet, and innovation is very likely to suffer, unfortunately. And that's the end. Ah!